Okay, this problem is an analytical geometry problem, and this is our first day of review. So let's look at this problem. If you'd like to give it a try before continuing, please do. And I am going to give you some of the formulas that are important in this particular problem. The distance formula, which is based on the Pythagorean theorem, is the difference in two x values squared plus the difference in two y values squared, and then you take the square root. We also, in this, have that the tangent of an angle is equal to the gradient, and that angle is the angle of inclination. And the gradient is the difference in the y points, if you have 2 points, over the difference in the x points, where the points are forming the line. And we also have the properties of parallelograms are important in this problem. And those are that the sides are congruent, equal, and parallel. Opposite angles are equal. And consecutive angles are supplementary, which means they add to 180. Okay, so if you would like to stop the video and now try the problem with that information, please do. Otherwise, we'll keep on going. Okay, let's get our head around this problem. We have information, coordinates are given to us, and the vertices of a parallelogram, and BC cuts the x-axis at point F, and DC cuts the x-axis at E, and diagonal BD is drawn, and we have an angle given 123.69 degrees, angle BFE, that's labeled, and BCD is labeled as theta, and the inclination of DE is alpha. Okay, so let's start. The length of DC. Well, D, we know, is the point -2, -5, and C is the point 2, -1, so we can use our distance formula. The length is equal to the distance. And that will be the square root of -2 minus 2 squared plus -5 minus a -1, all squared. So we get the square root of -4 squared plus -4 squared, or the square root of 32. They asked us to put it in simplest third form, so that will be 4 square root of 2. Okay, 2.1 is completed. 2.2, the gradient of DC. So the gradient of DC, this is related to the tangent of an angle is equal to the gradient of a line that goes with it. So if we look at our diagram, the gradient, the angle alpha is the angle of inclination. So the gradient of DC is just the slope. And we don't even need to know alpha to do this because we have 2 points. So we know, sorry, the slope is the word that I use for gradient, sorry. So the gradient formula equals y2 minus y1 over x2 minus x1. So that will be -1 minus a -5 over 2 minus a -2 from those 2 points. So that is 4 over 4, which is equal to 1. That is the gradient. It also happens to equal the tangent of alpha, but we don't need that yet. Oh, but that is what we need in 2.3. So the tangent of alpha will be equal to the gradient of DC, which we know is 1. The tangent of alpha is equal to 1. We notice that alpha is an acute angle, and the tangent of alpha equals 1. That means alpha will be 45 degrees. You can get that using your calculator.